Unit 8, Day 4 notes, as you can tell by looking at the screen. Today we're going to talk about two things. We're going to talk about symmetry, which is a word you're probably really comfortable with, and then something called compositions of reflections. Okay, symmetry and compositions of reflections. All right, so first let's take a look at symmetry. A figure with symmetry can be reflected onto itself or rotated onto itself. Reflected onto itself is something we're really used to, like you think back to your elementary school days when you cut something in half and it was the same on both sides. So that's one kind of symmetry, and then the other kind is where we rotate it, and that might be a little bit new. So line symmetry, that's the one we're comfortable with. It's sometimes also called reflectional symmetry. You think of the object on the other side of the line looks the same. It's a reflection. So it has a line of symmetry that divides the figure into just two congruent shapes, parts, however you want to think of it. Okay. An example right here, obviously we cut this heart in half right here, that's the line of symmetry. Rotational symmetry is the one that might be kind of new. So rotational symmetry, so if there is a half of a turn, so 180 degrees, or less, where the figure is the exact same. So for example, if you look at this star, if we were to turn this star 45 degrees, it would look exactly the same. It would be the same exact shape. To find the angle of rotation, all you have to do is take 360 degrees and divide it by the number of turns that are possible. So if you look right here at this one, this has 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8, and that's how I get 45 as the angle of rotation for that one. So if you take a look here, this is a more specific kind of rotational symmetry called point symmetry. Okay, point symmetry is when it's exactly 180 degrees. So if you think about it, if we took this letter S right here, and let me give you that nice looking S right there. If we were to take the letter S that I traced over it and turn it exactly 180 degrees, obviously mine is ugly and the one on there is not, but you would have 180 degrees rotation. It'd be the same exact thing. And when it's exactly 180 degrees, that's called point symmetry. All right, so example. So let's consider the following shape. So does it have rotational point and line or reflectional symmetry? What type does the flag have? So this flag here is the flag of Switzerland. So does it have rotational symmetry? And if yes, what is the angle? I think this one might be you could misconstrue it. If you turn your head sideways right now, how many of you are actually doing it? I am. It hurts. You turn your head sideways, and it's not exactly the same sort of plus sign, if you want to think of it as that. So it would need more than a 90-degree turn. It has rotational symmetry, but it's 180 degrees. Does it have line symmetry? Could you draw a line through it? We could draw a line right there, and it's the same on both sides. You can draw a line right there, and it's the same on both sides. You can't draw this one. That one doesn't work. Again, if you tilt your head, you can see that one doesn't work. So I said yes, it has line symmetry. It's got two lines of reflection. And then point symmetry, all I have to do is look right here. Because this is 180, or if this were a factor of 180, then that's a yes. It has point symmetry. 180-degree rotation works. So that's it for that kind. Then we have compositions of reflections. Composition of reflections really simply are when we have two congruent figures in a plane and they're mapped onto one another by a single reflection, composition of reflections, or glide reflections. So a composition of reflections is when we have multiple transformations onto one shape. What happens is when we have a composition of reflections, it ends up being one of two things. It ends up actually being a translation, or it ends up being a rotation. Now this is all very confusing to read. So let's do something other than read. Let's actually look at it. We look at this example right here of this arrow. So we have this shape right here, and we're reflecting it in line L. Okay, and then we reflect it again in line M. So we reflected it right here. It goes from red to blue, and then from blue to green. Okay, so what we're saying is it's two reflections. Okay, so this is one reflection and then two reflections. But what do you notice from red to green? Okay, from red to green, it didn't change orientation, it didn't change size or anything like that. It's actually from red to green. That is which transformation? Hopefully you said translation. Okay, from red to green, a composition of reflections in parallel lines is actually just a translation. Conversely, if we look at a reflection across intersecting lines, okay, we look at intersecting lines. If we take this first shape and we reflect it here, and then we reflect it again, these are intersecting lines. What actually happens is, instead of two reflections, this becomes a what? Hopefully you said rotation. Okay, so we take this shape and we, whoops, because we've reflected it in intersecting lines, this shape has actually been, let's see if we can pull this off, rotated to there. Okay, and actually we can make it look even better. Let's get some tools out here. Let's get an origin. This will help. So now if we look at that shape, we can rotate it and boom, there it is. So a reflection across, two reflections across intersecting lines is actually a rotation. Let's take a look at that. I'll walk you through this one. So we have name the rotation of image ABC after a reflection across line R and line T. Okay, so first of all, locating everything is important, right? This is line R, this is line T. So just locating everything is important. But let's look at ABC. So here's A, B, C. That's ABC. We have a problem. Let's do ABD. Let's change that to a D. Sorry about that, guys. So let's say ABD. We have this shape right here. When we reflect that across line R, and this one's line R, it becomes this shape. And then when we reflect that across line T, it becomes this shape. So a reflection, and we can check this using let's use this guy again. And if we rotate this, it should land right there, and it does. Okay. So if we look at ABD after two reflections, it actually is KLJ. Okay. So that's how we do that. A glide reflection. Okay, a glide reflection is a composition of a translation and a reflection. So first, the glide is the translate, and reflection obviously is reflection. Okay, so that's a glide reflection, translation and reflection. You always have to reflect before you glide or translate. So we reflect first, and then we shift it, and we move it. Okay, reflect and then translate. What I'd like you to do is, there's some practice here. I'd like you to try these. So you're going to reflect across the line. I'll help you out with the lines. X equals 0 is the y-axis. The line y equals 1 is here. So you're going to reflect first and then glide. Okay, reflect first and then glide. Y equals 1, again, that's here. All right, y equals x, this is harder. Okay. That's this line right here with a slope of 1 going through the origin. So you can do those four. Then there's some more questions on what kind of symmetry. Okay, what kind of symmetry? More symmetry questions. More symmetry questions. You can try all these. We're going to go over all these in class. 2 more questions on symmetry. And then quick review, quick reminder. Let's see if we can get these. A reflection of a figure across 2 parallel lines is a translation. A reflection of a figure across 2 intersecting lines is a rotation. And what is point symmetry? Point symmetry is symmetry that involves a figure being rotated exactly 180 degrees. Try those problems on your own. We'll check them together in class. That's it for the notes. I will see you guys next time. Bye.